cumulative value of an investment of 5,000, 10 years, interest rate 6.5%. If the money is compounded semi-annually, part B, quarterly, part C, monthly, part D, continuously. Okay, so first of all, we have to identify, I'm going to copy the two formulas here, P1 plus R over N raised to NT, and A equals PE to RT. First, let's identify what is given. Can anyone tell us what is the 5,000? What does it represent? Anyone?
Does 5,000 represent T?
Very good. Awesome. That's not a good color. Okay, that's the principle. Very good. What does 10 years represent from all these?
T.
Of course. And what does 6.5% not to be used as 0.065? What does it represent?
R.
Very good. Lowercase r. Perfect. Excellent. What does semi-annually mean? What does quarterly mean?
4.
Very good. What does monthly mean?
12.
Very good. And this is a totally different formula. Has nothing to do with n. So these three have to use the first formula for compounded n times a year. The last one has to use the second formula. Okay, perfect. So let's write them. Don't calculate anything. So I have 5,000. 1 plus 0.065 divided by 2 for part A, raised to 2 times 10 for part B, 5,000, 1 plus 0.065 divided by 4 raised to 4 times 10, and part C, A equals 5,000, 1 plus 0.065 divided by 12 raised to 12 times 10. And part D is a totally different formula, 5,000 e to the rate 0.065 multiplied by 10. So first of all, let's see what happens here with the first three. This becomes 2, and it becomes 4, and it becomes 12. So this is the only number that changes. I recommend, because this is very useful, go to y equals. Clear if you have anything in there. And let's put this as a function with x in the denominator and x here. So then we can punch in the numbers all at once and not have to do this 3 times. It's a very useful method. You can do whatever you want, of course. But I recommend 5,000 parentheses 1 plus 0.065 divided by x, because I'm going to change x first to 2, then to 4, then to 12. Close the parenthesis, put a caret, and in parentheses 10x, because it will change over there as well. Let me know if you need any help with this. If not, I will move on to second and table. Anyone? Okay, second and table. And I put in my numbers. 2, enter 4, enter 12, enter, so I don't have to do this several times. Please go back and highlight the number because we need the cents. So we need to round up to the nearest hundredth. So this will be 9479.19. The next one will be 9527.79. The third one will be 9. Yes?
Nope. I'm going back upstairs.
Okay. Is everything okay?
Sorry, my dog.
That's okay.
I forgot to mute myself.
That's okay. No worries. Good. And now, for the last one, I have no choice. It's alone. I'm not going to bother with it. Second and 10, e to the x, in parentheses, 0.065 times 10 and close. This calculator may not need parentheses around the power, but I don't know what kind of calculators you have, so I will always. Okay, so 9577.70. So this is our first touch to exponential functions, an application of exponential functions. Any questions? Any questions? Okay, let's do one more. So you see how many real life situations. I already showed you like 3. Here's another, 66. That's another tragedy that happened in 1986. Most of you were not on this planet then. It was a big tragedy. So in 1986 explosion, the 1986 explosion at the Chernobyl nuclear power plant in the former Soviet Union sent about 1,000 kilograms of radioactive cesium-137 into the atmosphere. The function f of x equals 1,000 times 0.5 raised to x divided by 30. Describes the amount f of x in kilograms, so this is in kilograms, of cesium-137 radioactive substance remaining in Chernobyl x years after 1986, which means x equals 0 for 1986. If even 100 kilograms of cesium-137 remain in Chernobyl's atmosphere, the area is considered unsafe for human habitation. Even if 100 kilograms are still in the atmosphere, the area is considered unsafe for human habitation. Find f of 80, which is 80 years. 80 years since 1986. So what is it? 2066. Okay, that's the same thing, right? 2066. So the question is, find f of 80 and determine if Chernobyl will be safe for human habitation by 2066. I don't have to do anything. I can never do this by hand. I just plug it in, put in the calculator. Be very careful how you put it in. So 1,000 parentheses 0.5 caret. I put it in parentheses. I simplify by 10. So I write 8 divided by 3. And the answer is 157.5. 157.5 kilograms still in the atmosphere. What would you tell the people who had homes in that area? If they are still alive, or their followers or relatives, should they go back to their homes in 20?
Tell them that by the year 2066, Chernobyl will still not be fit for habitation.
Exactly. Exactly. Thank you. That's another example of an exponential function. Okay. Very good. Moving on. So let's look now at logarithmic functions. Okay. So first of all, give me an exponential function, any exponential function you can use or you want to use now. So I can illustrate how the log function looks like, or how the log function works. You can give me just anything you want. You can give me 1/2 to the x. You can give me 2 to the x. You can give me 1/3 to the x. You can give 10 to the x. You know so many now. You can give e to the x. Choose one. It doesn't matter. So x equals 0, x equals -3, and x equals 4. And we want to determine, depending on which function you pick, we will determine the y values. Pick any pure exponential function you want.
11 to the x.
11 to the x. Perfect. So please plug in 0.
1.
Perfect. Please plug in -3. You will say 11 raised to -3 is 1 over 11 to the third, and I will use my calculator. I don't know what 11 to the third is. 1331. So it's 1 over 1331. Last one, 11 to the fourth. I have no idea. 11 to the fourth is 14641. This one here, 14641. So based on the function we picked, we determined 3 points, 0, 1. We determined -3, 1 over 1331. And we determined the ordered pair 4, 14641. Okay. This is a one-to-one function. You will have an inverse function. The inverse function will be denoted by F inverse like we always did. Don't write it just yet. My question is, for F inverse, can you give me 3 points?
1 and 0.
Of course.
1 over 1331 and -3.
Yep.
And then 14641 and 4.
Excellent. But I want to show you that this is true. Before I show you, I have to write a very important note, a very important result. I would say that this is the most important in this chapter, that any exponential equation can be converted, can be replaced, converted, etc., into a log equation, and vice versa. This is the most important result in this chapter, in my opinion. We're not going to write this. So this is the double equivalency symbol. Any exponential into a log, any log equation into an exponential, back and forth. We're not going to write this. This is for us in words. We are going to write this. Log base A of x is y. I haven't explained the notation yet. Is equivalent to, but please pay attention how we do it. From the base, counterclockwise. The base raised to y equals x. This is what I'm going to use, but after I explain the notation. What am I going to do with this? I'm going to show you that the function we have here as the inverse of this, when we apply it to 1, the result will be 0. When we apply to this number, the result will be -3. When we apply to this number, the result will be 4. I haven't showed that yet because I need this result first. Any exponential can be changed into a log. Any log equation can be changed into an exponential equation. Now I'm going to explain this notation because we have not seen this before, and then I'm going to use that to convince you of that. Back and forth. Okay, so here it is. Logarithmic function notation. The function notation is this. Log, log, base A of x. So we read this. Log base A of x. Log in base a applied to x. So this is a function. Let's call it g of x. What does it mean? It's the log in a particular base of x. What can the base be? Well, of course, the same thing. The same two options that we had before with the exponential function, because it's the inverse of the exponential. Exactly the same. Either a number greater than 1 or a number between 0 and 1, like 1/2, 1/3, 1/15, etc., etc. Okay, there are two special log functions. When we had 10 to the x, the inverse function is log x. You can say, where is the base? By convention, the base is 10. Such an important function, it has its own key in the graphing calculator. log. Log automatically means base 10. That's why it's paired with 10 to the x. These two functions are inverses of each other. 10 to the x and log. 10 to the x is exponential, log is log. Same thing with e to the x. E to the x is the exponential, natural exponential. This is common. And of course, this is common log function. Of course, this one will be ln. It should be nl, natural log. And you can say, where is the base? Well, the base is e. E to the x and ln. It comes from German, that's why it's ln instead of nl. So it's natural log. It has base e. The two are paired because they have the same base, e to the x and ln. Both base e. So these are the two special. So notation could be three different things, basically. Log with no base, but we know that the base is 10, but we don't write it. Ln with no base, but we know the base is e, but we don't write it. And anything else. But anything else restricted to numbers greater than 1, not 1, or between 0 and 1, not 0, not 1, and not negative, of course. Okay, so now I can come back to this. So if the exponential function has, that we picked 11 raised to the x, can anyone have an idea of how will I denote the log function that is the inverse of this? What do you think? What will be the notation? When the base here is 10, the base here has to be 10. When the base here is e, the base here has to be e. Otherwise, they will not be inverses of each other. If here the base is 11, I have to use the notation log, but what will be the base?
11.
Of course, of x. These are inverses of each other. They must have the same base. They will not be inverses of each other if they don't have the same base.